So I'm going to be working not every problem on this review because some of these are designed to repeat like the same kind of problem, just different numbers. So I'm going to be doing an example for every type of problem that you're going to see on the TEKS test using this TEKS review. Okay? So the first problem that we're going to work is problem 1A. Just a second here. Okay, so it says transform ABCD to A prime, B prime, C prime, and D prime. It has a center of 2, 2 and a scale factor of 2. So what this is showing you is that it wants us to do a dilation where the center of dilation is not at the origin. And so this is going to require 3 steps. First, you need to subtract the center of dilation. Second, you need to multiply by the scale factor. And third, since you take away the center at the beginning, you have to add back the center at the end. Okay? Okay, so with that said, here's our coordinates. So let me see if I can get this all in the frame. All right, so A is at the coordinate -3, 3. B is at 3, 5. C is at 5, -1. And D is at -1, -1. All right, so step 1 is that we need to subtract the center from each coordinate. So I'm going to subtract 2, 2 from each of these. Okay. All right, so -3 minus 2 becomes a -5. 3 minus 2 is 1. So that's going to be 1. 5 minus 2 is 3. 5 minus 2, 3. -1 minus 2 becomes a -3. And so this would be -3 and -3. Okay? All right. So we subtracted the center. Our next step is that we need to multiply by the scale factor. So everything has a scale factor of 2. Okay, so I'm going to multiply by my scale factor of 2. So this is going to become -10, 2. Okay. This is going to become 2, 6. 6, -6. And -6, -6. Last step is that we need, let me see if we can get a different color. We took away the center at the beginning. Now we need to add it back. So I'm going to add back 2, 2. To each of these. -10 plus 2 becomes a -8. 2 plus 2 is 4. 4, 6 plus 2 is 8. 6 plus 2 is 8. -6 plus 2 is -4. And so that would be -4, -4. Okay. And these are our final coordinates that we want. Okay. All right. So plotting that, we've got -8, 4. 4, 8. 8, -4. -4, -4. All right, so 8, 4, -8, 4, 4, 8 is A prime, B prime, and then we've got C is at 8, -4, and D, -4, -4. Okay. Okay. And when you're done, the shape should resemble the original shape, and ours does, so that's a clue that we did this correctly. Okay, number 2. This wants us to rotate 90 degrees counterclockwise and then translate it down 3 units. Alright, so I want to remind you of this card trick. So you start by putting your x and y coordinate on the front, and on the back you have negative x and negative y. Okay, so this is to represent that you start with your regular x and y coordinate, and then as we rotate, it's going to change the rules each time we rotate. So default position to rotate is counterclockwise, which is this way, going around in a circle counterclockwise. Okay? So one 90-degree rotation would be 1 turn counterclockwise. So this is our 90-degree rotation rule. Okay. 2 turns would give us our 180-degree rotation rule. So that's negative x, negative y. 3 turns would give us our 270-degree rotation rule. And 4 turns takes us back to where we started at xy, which is a 360-degree rotation. Okay. Okay, so since this is a 90-degree rotation, we're going to be using this rule, negative y, comma x. So let me get some scratch paper here. Okay, so taking our original coordinates, we have A is at 3, 8. B is at 8, 1. C is at 2, 2. Okay, so I'm going to apply the negative y, x rule to each of these coordinates. Alright, so what this rule means is that you're going to swap out your x and y, and then your original y value is going to change sign. So this will become negative 8, 3. This will become negative 1, 8. And that's negative 2, 2. Okay, so they switch places, change sign. Okay, this is your 90-degree rotation. Okay, but after that, it wants us to translate down 3 units. Okay, so if you move down 3 units, that means you want to subtract 3 from the y value. If you're moving left or right, that's either going to add or subtract to your x. When you're moving up and down, that adds or subtracts from your y. Okay, so I'm going to take each of these and subtract 3 from the y value. So this is going to become negative 8, 0. 3 minus 3 is 0. This will become negative 1, 5. 8 minus 3 is 5. And that'll become negative 2. 2 minus 3 would be a negative 1. Okay. And so these are our final coordinates where we end up. Alright, so we've got negative 8, 0, negative 1, 5, negative 2, negative 1. Okay. Alright, I'm going to plot that on my graph. So there's my A prime, B prime, and C prime. Okay, and there's our new figure. Alright, next example I'm going to do is 3a. So this wants us to reflect reflect a triangle across the equation x is equal to negative 1. Okay. So when you're doing a reflection, essentially you want to create a mirror image of what this is on the other side. So the first thing that we have to do here is we need to actually draw this line x equals -1 so we can see where we need to reflect over, whether that's vertical or horizontal. Okay. All right, so to remember whether x equals is a horizontal or vertical line, some students use this, okay, Hoy Bucks, where H stands for horizontal. This stands, the O stands for 0, slope, and y equals. Okay, so if it's a horizontal line, it's going to be a y equals equation and have a 0 slope. V stands for a vertical line, okay, an undefined slope, and an x equals equation. So what that means is that this line here is going to be a vertical line. Okay. All right, now these are good memorizing tools, but if you really want to understand why it's a vertical line, you can read this like a sentence. It's saying x equals -1, or in other words, x is always -1 on this line. Okay, that's what that means. When you're saying x is equal to -1, you're saying x is always -1 on this line. Okay, so if you plot every coordinate where x is -1, so like -1, 0, -1, 1, -1, 2, -1, -1, and so on, okay, here's all those points. So as you plot all of the points where x is -1, it becomes very clear that this is a vertical line where all of your x's are -1. Okay, now that we've plotted this line, reflecting is as simple as counting how far away each point is and putting it that same distance on the other side, just reflecting it like a mirror image. So we can count. C is 1, 2, 3 away, so I can go 1, 2, 3 on the other side. 1, 2, 3, 4, so 1, 2, 3, 4. There's A. And B is 1, 2, 3, 4, 5, 6, 7. Oh, wait. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Connect those. Okay. So A prime is at -5, 8. B is at -10, 1. And C is at -4, 2. Okay. All right. So if you flip to the back side, okay, here we have our determine if it's right, obtuse, or acute. So what this is about, if something is a right triangle, then it's going to follow the Pythagorean theorem, which says that a squared plus b squared is equal to c squared. Okay? So sometimes I show my students this kind of visualization. So visualize, you know, we have this right triangle. Here's A, B, and C. Okay? All right. So this is a right triangle. If we were to keep A and B the same length, but we needed to make C longer. So making this longer, but we have to keep those about the same length. Okay. You can imagine that's what's going to happen to this angle. is this angle is going to become obtuse, because as we stretch this out, that 90-degree angle will become larger. So what this means is that when c squared is greater than a squared plus b squared, it creates an obtuse triangle. Okay. Now on the other hand, if you were to do the opposite and squish, so we have A, B, and now I'm going to squish C and make it smaller, this becomes an acute angle. So whenever c squared is less than a squared plus b squared, that creates an acute triangle. Sometimes I like to use my own pins as an example. So like, you can imagine, now you sort of have to imagine the third line here, but if I put my pins together, forming a 90-degree angle, okay, so here's my right triangle where a squared plus b squared equals c squared, okay? But if I were to stretch this out and I make this longer, so now c squared is larger, obviously this angle is becoming greater than 90. But on the other hand, if I take this and squish these inward, so now c squared is smaller, then this becomes an acute angle. Okay. Okay, so with that said, now we can classify these. So c is always going to be your largest number out of the three. So if I've got 3, 4, and 5, then 5 is the c. Okay, so now what we do, you type in your a squared plus b squared, so 3 squared plus 4 squared, and that's equal to 25. Okay. Type in your 5 squared, that's also 25. So if they're equal, that tells me, okay, this is a right triangle because they're equal. Okay. All right, if my c is 13, okay, so I've got 7, 13, and 12. 13 is the largest, so that's c. So I would type in 7 squared plus 12 squared, and that's equal to 193. 13 squared is equal to 169. So in this case, my a squared plus b squared is greater than my c squared. If we look at what that means, if your a squared plus b squared is larger than your c squared, that means it's an acute triangle. All right, last, I've got 15, 6, and 17, so that's my c. Type in 15 squared plus 6 squared, that's equal to 261. Okay, 17 squared is equal to 289. So in this case, my c squared is bigger than my a squared plus b squared. So that means that this is an obtuse triangle. Okay, we're getting close to 20-minute runtime, so I'm going to pause the video so that it doesn't take too long to upload, and I'll continue the other examples in the next video.